This is section 3.1, solving linear systems by graphing. Now, most of you have done this before in Algebra 1 and again in geometry, so this will be a review for you. So how do I solve linear systems by graphing? Well, first, a linear system of equations is just two or more equations together. Okay, a solution to a system is an ordered pair that satisfies both equations in the system. So what that means is an ordered pair, remember if you think of what an ordered pair is, it's just a coordinate. So we have an x, y ordered pair that satisfies both equations in the system. So if I have a point and I plug it in for x and y into one equation, it must also work for the other equation to be the solution to the system. It is also the point where the graphs of the two equations intersect. So we'll find that a little later. So it says graph the linear system and estimate the solution. Then check the solution algebraically. So we're going to start by graphing this system. Okay, we have 4x plus y equals 8 and 2x minus 3y equals 18. Well, I can't graph those as they are right now, so I need to solve the equations for y. So first I would have 4x plus y equals 8, and I would subtract 4x from both sides in order to get y by itself. So I would get y equals negative 4x plus 8. Okay, and then I'm going to have 2x minus 3y equals 18. And so I would subtract 2x from both sides because I'm trying to get y by itself. So these will cancel out. And I'll have negative 3y equals negative 2x plus 18. So keep in mind you can't put these together because one has an x and one doesn't. Okay, then to get y by itself, I need to cancel out the negative 3 by dividing. So I would get y equals positive 2/3 x minus 6. When I take a negative divided by a negative, remember that that turns positive. So now I can graph these equations together. So I'm going to graph both equations using slope-intercept form on the same graph. I'm going to write these over here so I have them. Y equals negative 4x plus 8, and y equals 2/3 x minus 6. Okay, so if I go to graph these, the first equation, my y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. And my slope is negative 4 over 1. So I would go down 4, 1, 2, 3, 4, and right 1. 1, 2, 3, 4, right 1. And I'm going to continue doing this for a while, just because I'm trying to find the point where these two graphs intersect. That's the solution to the system. So what I need to do is I need to keep going so that in case they cross, like down here, I'll have points. So now I'm going to draw my line. Do blue. And make sure that your lines have arrows on both ends. Make it illustrative. There we go. Okay. Then I'm going to graph the second equation. So my y-intercept is negative 6. 1, 2, 3, 4, 5, 6. And my slope is positive 2/3. So I would go up 2 over 3. And look, that is going to be the point where my two lines cross. Right there. So I need to tell what is the solution to my system. Well, the solution to my system is the point where these two lines cross, which is this point right here. So I need to give the location of that point. So if you were telling someone, go to this point, what would you say? you would say go over 1, 2, 3, and down 1, 2, 3, 4. So my solution is 3, negative 4. That is the solution to the system. Now it asks me to check my solution algebraically. So what that means is I'm going to plug it back in to both equations to make sure that it works. So in case you didn't have those two original equations, these were my two original equations. So to check these, I'm going to plug in my solution, and for x and for y. And that's how I check my solution algebraically. So I'm going to plug in 3 for x and negative 4 for y. So if I plug that in, I get 4 times 3 plus negative 4 equals 8. So I get 12 minus 4 equals 8, and that is true. So that works. So it works for the first equation, but to be a solution to the system, it has to work for both equations. So I have to check the second one. So I'm going to plug in 3 for x and negative 4 for y. So 2 times 3 would be 6. Negative 3 times negative 4 would be 12. And 6 plus 12 is 18. So that's how I know that my solution is correct. So if you aren't sure if you graph them right, you can go back and check your solution algebraically. Okay, now we have three different types of systems. We have consistent, inconsistent, and actually, I'm sorry, I misspoke. There are two different types of systems. There's either consistent or inconsistent. Okay, so consistent is a system that has at least one solution. So the previous example that we had, it had a solution of 3, negative 4. So it would be a consistent system. Okay, now if it's inconsistent, that means that it has no solution. So let's think about what that means. Okay, the solution of a system is the point where the graphs intersect. So how would it be possible for them to have no solution? They would have to be parallel lines. If they are parallel lines like this, then they will never intersect. So that would be solution, no solution. Inconsistent is when they're parallel. Okay? Then if a system is consistent, it can be either independent or dependent. Okay? So if it has a solution, it can be independent, which means it just has one solution, like the system that we did before when it had the point 3, negative 4 as the solution. That would be consistent and independent. Okay? Then dependent, it was when the system has infinitely many solutions. So for example, if I had two lines or two equations that were the exact same equation, then that would be infinitely many solutions because I would have, let's say, like I had y equals 2x plus 5. And then let's say I had negative 2x plus y equals 5. And that was my system of equations. Well, if I add 2x over to the other side, then I would get y equals 2x plus 5. So they would be the same exact line, and therefore they would cross at every point possible, so it would have infinitely many solutions. So that would be an example of consistent and dependent. So this is how I remember the difference between the two. Independent is like by yourself, right? So if it has exactly one solution, it is independent. And if it has multiple solutions, then it would be dependent. Okay, so we kind of already talked about this, but this is just for you visual learners. Okay, if a system has exactly one solution like this, they cross at exactly one point, then that would be consistent and independent. Independent means one. Okay? If it has infinitely many solutions, they're going to be the exact same line, so they're going to cross each other infinitely many times, so that's going to be consistent and dependent. And then if the lines are parallel, then that would be inconsistent. All right, so let's take a look at some systems that have infinitely many solutions. So they want us to solve the system, and then classify the system as consistent and independent, consistent and dependent, or inconsistent. So if we look at this, we need to solve the system, so we're going to try to graph it. So before we can graph it, what do we have to have? Before you can graph these, you need to get y by itself. So they need to be in slope-intercept form. So if we go ahead and solve both equations for y, then we would have 4x minus 3y equals 8, and I need to get y by itself. So I would subtract 4x to cancel that out. Those cancel out, and then I'm left with negative 3y equals negative 4x plus 8. So then I'm still trying to get y by itself, so I need to divide by negative 3. So I get y equals positive 4 thirds x minus 8 thirds. So I got lots of fractions. That's okay. Then my second equation is 8x minus 6y equals 16. So I'm trying to get y by itself, so I need to cancel out the 8x, and I'm going to do that by subtracting. And I get negative 6y equals negative 8x plus 16. So then I'm trying to get y by itself still, so I would divide by negative 6. And I want to make sure that I can reduce my fractions if possible. So I would get y equals, this would turn positive, and 8 over 6, I can divide both of those by 2. So this would be 4 thirds x. And then 16 over negative 6, that's going to be a negative number. And I can divide both of these by 2, so that would be 8 thirds. So what do you notice about these two equations? They are the exact same line. So if I was to graph them, they would cross infinitely many times. So how would I classify this system? Would it be consistent or inconsistent? Well, it has solutions, so it's going to be consistent. And then I have to decide, would it be independent or dependent? Well, independent means one, and this has more than one solution, so this is going to be consistent and dependent. So since the graphs would be the exact same line, there are infinitely many solutions. So it would be consistent because it has solutions, and it would be dependent because it has many, many solutions. All right, last thing, systems with no solution. So let's solve the system. And then we're going to classify the system as consistent and independent, consistent and dependent, or inconsistent. So same process. We're going to solve both equations for y. So we have 2x plus y equals 4. So we need to subtract 2x to get y by itself. And we get y equals negative 2x plus 4. And for the second equation, we have 2x plus y equals 1. So we would subtract 2x to get y by itself. And we get y equals negative 2x plus 1. Now, if I look at these equations, there's something that they have in common. Okay, they both have a slope of negative 2. So what kind of lines are they going to be? They would be parallel lines. So because they have the same slope, they would be parallel, and that means that they do not intersect, so there would be no solution. So would the system be consistent or inconsistent? Because it has no solutions, it would be classified as inconsistent. Okay? All right, make sure you go back and answer your essential question. How do I solve linear systems by graphing? And then I will see you in class tomorrow. Also, don't forget that you need to chunk your notes into sections this time. So you need to divide your notes into sections, however you'd like to do that, and then you need to write a question in the left-hand margin for each section that you made. Thank you.